Hi, my name is Claudia Kemp, and this is my Zoom report for Written Exam Module 3. Number 1 starts by asking you to use divisibility rules to see if these numbers along this vertical line will divide evenly into the numbers along this horizontal line here. So for number 2, the rule states that if the last digit in the number is an even number, then it will divide evenly. So those have been filled out as so according to that rule. The rule for divisibility of 3 states that if the sum of all of these digits added together is divisible by 3, then the number is divisible by 3. So that has been done along the line here. The rule for 4 states that the last two digits are divisible by 4, then the entire number is divisible by 4. 84 is divisible by 4, therefore 684 is also divisible by 4, and that has been done so on. Number 5 is really simple. It states that if the last number is a 5 or a 0, then the number is divisible by 5. 684 ends in a 4, not a 5 or a 0, therefore it is not. But 644,490 ends in a 0, therefore it is divisible by 5. 6 states that if it follows the rule for 2 and 3, then it is divisible by 6. So 684 is divisible by 2 and 3, therefore it's divisible by 6, and that has been done along the line as well. Number 7 is a little more complicated, and I will come back to that later. Number 8 states that if the last 3 digits are not divisible by 8, then the whole number is not divisible by 8, and that has been solved along the line here. Number 9 is quite like number 3. It states that if the sum of the digits is divisible by 9, then the entire number is divisible by 9, the original number. So that has also been done. 10 is incredibly simple. It states that if the number ends in a 0, then it is divisible by 10. So this one doesn't end in a 0, this one does, and so on. As I said, number 7 is a little complicated. The rule states, or a rule states, that if you take the last digit of a number and subtract it from the remaining digits, or double it, then subtract it from the remaining digits, divide that number by 7. If that number divides evenly by 7, then the original number divides evenly by 7. So you have 684, so you take 68 minus 4 times 2, because 4 was the last digit, equals 60. 60 divided by 7 equals 8.57. So no, because it did not divide evenly. Then you have 644,490, which will become 64,409 minus 0 times 2, which is still 64,409, divided by 7 equals 9,207. So yes, that divides evenly. That is the rule for number 7. And then I have all of those rules written out here, just as I had said. Okay, and then that takes quite a bit. All right, question number 2 asks that you check each answer by the process of 9s. I have the process of 9s explained right here, but it basically takes each number in the equation and divides it by 9, and then takes the remainders of those numbers, of those equations, and solves the original equation with the remainders. So 416 divided by 9 has a remainder of 2. 7,490 also has a remainder of 2. 69,844 has a remainder of 4. Added together, that equals 8. The original answer, 112,790 divided by 9, has a remainder of 2. So since this remainder of 2 and this remainder of 8 do not match, the problem does not check using the process of 9s. And that is continued through parts B and D. Parts B through D. So I'll do part B with you. 8,550 divided by 9 is even, so there's no remainder. 6,888 has a remainder of 3. 2,525, remainder of 5. 6,029, remainder of 8. Added together, that equals 16. The original answer was 23,892 divided by 9 is a remainder of 6. 6 does not equal 7, therefore the problem does not check. And that is continued through part D. Now, number 3 asks that using colored rods and measuring rods that you solve the following problems. So part A asks that which rods will evenly measure the 9 rod. So you would just find the divisors or factors of 9, which would be 1, 3, and 9. And those are all the rod sizes that will evenly measure a 9 rod. It asks the same for a 6 rod, which would be 1, 2, 3, and 6. And then part C asks that using the numbers you found in parts A and B, 1, 3, 9, 1, 2, 3, 6, that you would find the greatest common divisor between 6 and 9, which would be 3, because it's the greatest number they have in common. Parts D asks which rods will evenly measure an 18 train. So again, the factors of 18, 1, 2, 3, 6, 9, and 18. And then part E asks how you would explain greatest common divisor using the rods. And you could say something along the lines of the greatest common divisor of two numbers is the length of the longest rod or train that will measure both evenly. And then I go to explain here what different ways to use it in the classroom, different purposes of the rods, etc. Now, question number 4 is a method for finding LCM between numbers, and that this method is explained right here. So part A asks to find the LCM between 48, 25, and 65. So you would make this chart like so. You put 48, 25, and 65 on the top, and then you would pick a number to divide them by. So a prime number to divide them by. So 5. 5 does not divide evenly into 48, so you bring 48 down. It does divide evenly into 25 and becomes 5, and it also divides evenly into 65 and becomes 13. 5 and 13 are prime numbers, so we don't try to divide them anymore. 2 is a prime number that will divide into 48. It becomes 24. 24 divided by 2 becomes 12. 12 divided by 2 becomes 6, and 6 divided by 2 becomes 3, which is also a prime number. So since these were primes, they followed all the way down, and now all of these prime numbers along the edges are the LCM. So the LCM would be 5 squared times 3 to the first times 2 to the fourth times 13 to the first. And that is continued through parts C, I believe. Yes, through part C. I'll do part B with you. Part B asks for the LCM of 40, 12, 44, and 363. So divide them all by 2. 40 divided by 2 is 20, 12 divided by 2 is 6, 44 divided by 2 is 22, and 363 is not evenly divided by 2, so we just bring that down. 20 divided by 2 is 10, 6 divided by 2 is 3, 22 divided by 2 is 11, and 363 divided by 2 is, again, not even. 10 divided by 2 is 5, 3 divided by 2 is not even, and then neither are the rest of them. All right, so divide them by 3. 5 does not divide evenly by 3, but 3 does, so it equals 1. 11 does not divide evenly by 3. 363 divides evenly by 3 and equals 121. So let's divide by 11. 5 does not evenly divide by 11, neither does 1. 11 does. So 11 divided by 11 equals 1. 121 divided by 11 equals 11. So the LCM of 40, 12, 44, and 363, would be 2 cubed times 3 to the first times 11 squared times 5 to the first. And that would be the exact same way that you would do part C as well. Question 5 is a word problem involving gears. So the word problem asks that you have a smaller gear with 48 teeth and a larger gear with 84 teeth, with teeth A and B on the larger gears, touching. And so it asks how many more revolutions will the small gear have to make before A and B are in the same position again. So you would take the LCM of the teeth of both gears. So the small gear has 48 teeth, the large gear has 84 teeth. Whatever method you choose, you would find, or you should find, that the LCM of these two numbers is 336. The problem asks how many more revolutions the small gear will have to make than the larger, so you would take this LCM, 336, and divide it by each number. 336 divided by the smaller gear of 48 equals 7. 336 divided by the larger gear of 84 equals 4. 7 minus 4 equals 3. Therefore, the smaller gear makes 3 more revolutions. And the final problem, number 6, is a little fun one. It asks that you make a magic square using integers -7, -6, -5, -4, -3, -2, -1, 0, and +1. So to solve this problem, you would take all of the integers just mentioned and add them together like so, and it would equal -27. So once you have calculated that answer, you will divide -27 by the number of rows in the box, which would be 3. So 3 here, 3 here, it's 3. So -27 divided by 3 equals -9. This number, -9, should be the sum of each row, diagonal, and column once the box is solved correctly. So you would then use guess and check or trial and error method to find out how the box is solved. 0 and 1 were given, so 0 minus 5 minus 4, -9. 0 minus 7 minus 2, also -9. -5 minus 3 minus 1, -9. -4 plus 1 minus 6, also -9, and the -9 equals that in the diagonal as well. And this diagonal also equals -9. All the rows equal -9. So that is my exam. Thank you so much for watching. Let's see if I can turn this off.